So today I'd like to talk to you about the types of waves. It turns out that there are two main categories that waves can fall under. They are transverse waves and longitudinal waves. Let's take a look at each. So with a transverse wave, our energy pulse is moving one way, and the vibration of the particles is happening at a right angle to that. That is known as a transverse wave. I like to think of it as transverse. It's like a T. Okay, it forms a right angle. Vibrations are at a right angle to the energy. With the longitudinal waves, the particles are going to be vibrating back and forth like this, and the energy pulse is going to be moving in that same direction. The energy pulse will be parallel to the oscillations. So you're going to get areas of compression and areas where the things are spread apart. So let's take a look at these so we can see what I'm talking about. So here's a slinky, and you can see the person compressing the slinky at one end. These compressions don't stay localized, but propagate to the right. These oscillations are in the same direction as the energy travel. You can see the high pressure where they're compressed together. This would be a wavelength. Okay, so this would be a longitudinal wave. Here's an animation I made of a longitudinal wave. Again, it's like the slinky. And you can see that I'm moving just this end of the slinky, back and forth, back and forth. The energy pulse is moving in that same direction. Okay, and you can see that each piece is just oscillating back and forth if you watch any one of them. They don't actually go anywhere. They just oscillate in place. You can see a wavelength between the two high pressure regions, and this wave is known as longitudinal. Contrast that with a transverse wave, and you can see the energy traveling from the guy's hand to the support, and the oscillations are taking place at a right angle to that. That is transverse. Again, longitudinal. And here's a sound wave. And I have little bits of cork dust in there. And you can see the cork dust is oscillating back and forth like this as the sound wave is moving away from the speaker. So a sound wave is longitudinal. Okay? With your sound wave, you might want to draw something that looks like this. This is the speaker. It moves back and forth. It compresses the air in front of it. It spreads the air out as it moves backwards. These compressions are going to be high pressure. The part where they're spread apart is going to be low pressure. This would be the wavelength of your wave. And again, this would be the amplitude of your wave. How much the pressure deviates from normal atmospheric pressure. So this is a sound wave. Sound waves are longitudinal. Sound waves are pressure waves. This average would be normal atmospheric pressure. The higher the amplitude, the louder it is. Okay, so again, here's your animation of the sound wave. And then with a light wave, it's transverse. So you'll have your electron oscillating up and down. The electric field around the electron will be oscillating. And it will be oscillating up and down as the energy is traveling away from the source. Transverse for light, longitudinal for sound. Okay, so that's it for your different types of waves.